Hi guys, in the last video we have done the setup for running Gemma 4 locally via LM Studio and then connecting it via the Pi harness. And in this video I will be testing that setup. We will be testing it with a couple of scenarios that I have. And at the end I'll share my experience and my thoughts around it. And if you are somebody who stumbled upon this video directly, this is part 2 of the previous video. I'll recommend you guys to check out the first video and then come to this one. So, without any further ado, let's dive straight into it. Let us start with a quick sanity check. I want to show you guys that we are actually using the local model. So, as you can see, I'm in my terminal and I will spin up pi by just typing pi. And you can see this is the model that I'm using, which is Gemma 426p. And now I want to take you back to the LM Studio first. As you can see here, there are no logs. Now I'll fire a query in PyAgent and we should be seeing some logs here. Tell me in one sentence which model are you using? And if I take you back in the meantime to the LM Studio from the logs, it has finished streaming response. It was doing prompt processing. And if I go back to my terminal, I should have a response ready. Answers that I am an AI assistant operating within the Pi coding agent harness. Having gone through the quick sanity, now let's start with the testing part. So for the first test, as you can see, I've spinned up Pi inside a real project. So this is a posture fixing app that I created called Slouchy. So I'm inside that repository. And in here, the idea is I want it to be able to read the file in the repos, read the instructions and everything. So basically, I want to see the reading capabilities and if it is able to understand the repository before moving on to more complex tasks. I want you to read the main package files in this repository and also the custom instructions that are there. And once you have gone through the code, then give me like a map showing that how the repository works. At this point of time, do not edit anything in the repository. So this is the prompt that we will use. Now let it cook for some time. As you can see, it has started listing the files and directories that are present in this repository. So now it's trying to find the custom instructions. One thing that I've noticed is if you are using this local setup, then it is slower as compared to the speed at which Claude Code or Codex gives us response. And all of that is because this whole setup is running on my personal laptop. We are running it locally. So keep that in mind. If you're using this local setup, you need to be little patient to get the response. So now it's trying to find the custom instructions, but since I don't have a agents.md file or a claude.md file, it is struggling to find those instructions. So it is checking in different places to see if there's some sort of custom instructions present. What I really like here is it's trying to read the contents again and again. It checked for custom instructions in the hidden folders. Now it's again checking the root directory just to be sure that it didn't miss anything. So it's actually verifying things before giving me a response. And as you can see at the bottom, out of the 262K context window, 14% has been used so far. It's not necessary that there will be custom instruction. If it is present, then you should read it. And this is another thing that I like. This is very similar to how I work in Codex. So let's say if I've given a prompt and the AI is generating responses, and in between I have to steer the whole direction, I can give in another prompt and it will pick it up from there. So that's what happened just now. It started working on the other prompt that I've given in. Now, the fun thing to note here would be like, as I have given the second prompt, will it still remember the first task that we have given it? And will it give us the overall map? Or this will just end after answering this latest question that we have? By the way, if you see a lag in my voice and my video, then it could be due to this local setup being running, and at the same time I'm recording it. So it can be a little exhausting for the laptop to take the load. After working for some time, as you can see, it is saying that it is having enough information to create a map. So that means it remembers the first task that we have given it. And let's wait for some time for the final response. In the recording of the video, I will be trimming in sections where it's taking time so that you can actually see the response pretty quickly, but it's taking a lot longer than what you see in the video actually. So the text that you see in gray is the model in its thinking mode. And now whatever text that we see in white, that's the actual response. So it says it has completed a thorough review of the repository, and here's a map of how Slouchy works. So first, it's giving us the application entry points. It's listing the different Python files and mentioning what each of the file does. Then it's coming to the intelligence engine, which is the posture file that we have. And it says for detection, we are using media pipe pose to extract landmark coordinates from the webcam. And then we calculate 7 independent scale invariant metrics. So that part is actually correct. So as you can see in the data flow summary, instead of drawing the actual arrow, it says right arrow. So you can see it all starts from webcam and then it goes to media pipe. From media pipe, it goes to posture detector and all the way till the audio player, which is scolding us. So this is the response for the first test we have done. And I feel it has done pretty good in describing about the repos. It was able to go through all the files. Of course, it took a long amount of time, but correctness wise, it seems good to start with. After having tested the reading capabilities, now let's ask the Pi agent to find a small improvement in this repository that could be done. Find one small improvement that is safe to make. Before editing anything, show me the changes, explain me why it is useful, and tell me what sort of commands you will run after doing the changes to verify if the fix is actually accurate and working fine. Now let it cook. There are two things that are happening in this prompt. First, I've kept the scope to be small, and then I've asked it to propose a verification plan so that it doesn't change file on its own and say it's done. So I'll review the changes, and if it looks good, we will approve it. As you can see, it proposed at least 7 small improvements. And so ideally, if you are testing a new setup and you don't trust the model and the setup, this is one of the best ways to do it. Like ask it for small task and then ask it for the verification so that it knows what it's talking about before editing anything at all. So at this point of time, it is not settling for one improvement. It is going through all of the improvements that it has suggested and then seeing if the fix is needed or not by actually going through the code. So it says, how about improving the audio playback logic to prevent multiple sounds from overlapping if they are triggered very close together? And then it realizes it already having this if logic in the code. And it moves to the next improvement. Now, as you can see, we are getting the response. It says it has identified a small but critical improvement that makes the application significantly more robust against common real world scenarios. And the problem that it has identified is if somebody is downloading the file and the download is interrupted, let's say there's no internet connection, or let's say the user closes the app in between the download, then what happens is there is a partial corrupted file that is left on the user's disk. And because the code checks for that file path, the app will think that the file exists and it will skip the download. And when it tries to run it, it will crash immediately. So that's not a very good user experience. I agree with it. And now the proposed improvement that it is suggesting is it's saying to modify the posture.python file to implement atomic downloads combined with the minimal integrity check. So what it is proposing is it's saying that it will modify this method to check the integrity. So instead of just checking if the file exists, it will check if there is a valid size which is greater than 25 MB, and it will download the file to a temporary location instead of the final destination. And only if the download completes successfully, then it will move the temporary file to the final location. Now, moving on to the next part, why this might be useful. So, it prevents broken state. The application can never get stuck in a state where it thinks it has a valid model while actually it has a corrupted one. And if the previous download failed, the app will automatically recognize that the file is invalid and attempt a clean download on the next startup. So it seems pretty useful when thinking about the app downloading experience from the end user's point of view. And this is what the verification plan is. It will manually create a fake model file at the path location, basically a small file, and then it will attempt to run the main.python file. And without the fix, the app should see the file exist and then it should crash. And after the fix, it will again test it out. And this time, after the fix, the app should detect the file is too small and it should begin a fresh and safe download of the actual model. Hmm. So actually, this improvement and the verification plan looks good to me. So let's move on and ask it to do the changes. Yes, proceed with the changes and run the verification plan. So let it cook for some time. And this is going to be the real test for the setup. It then crashed with the Python exception, but rather it terminated with this code 124, which stands for timeout. So it then tried to make the file completely empty. And again, we got the same timeout code. We didn't see any Python trace back here. So it said that it didn't see the Python level crash, but it will implement the improvement as requested. So here is the implementation that needs to be done in this ensure model function. And yeah, it's applying the fix. Post that, it's running the verification plan. And the weird thing that was happening was the result of this command where it's running the main Python file, it was stuck for like 14-15 minutes. And then I had to kill the session and again spin up the same session. Then I asked it like why it took so long. It says it wasn't actually stuck, it was downloading a file and it was silent because the progress bar was updating a line that hadn't been completed with a new line yet. So I asked it again to continue with the proposed changes and then run the verification steps. So it's following the same steps and it says that it has applied the improvements to this posture file and verified the fix. And it gave me these results. But I wasn't so sure about the verification part. So I cross questioned it like, can you show me step by step where the simulated failure is happening? And told about the same error which it was not able to replicate earlier. Now it's taking a deeper look at the logs and it says that, okay, the app didn't throw a Python traceback, but it silently hung and was eventually killed by the timeout command. So now it tells me a step-by-step process of how the verification was done. And then again, I questioned it about the third step, which is running it after the test. And on questioning it again and again with the statements that it's making regarding the verification or whatever claim the model is doing, it says that it had made a mistake in the previous assessment and it reported a success that was not supported by the actual logs, which showed the application still hanging. So it says the success was a false positive. And then it's talking about the failure that occurred was due to the way the test environment was set up. And it is actually downloading the model, which is of 29 MB. So it says that the verification was successful. And if you see the context window, throughout all these conversations, we have reached 34% of the total context window, which is okay, I feel context wise. But it seems like it's kind of stuck here. It's giving me the same statements again and again. So I guess I'll have to kill this session again. And now we will restart the same session. Okay, it seemed that earlier it was testing or corrupting a file at not the correct location. So it says now it wants to corrupt the correct file, not the one in this folder. Let's see if that observation is true. So if you see, again, it says the test was a success, and then it says we could see the messages where it was downloading the model, and we could see this message for good posture. And yeah, it says the application can now survive a corrupted model. But let me ask it again. Are you sure about the claim that you are making that the test was actually successful and it was not crashed or stuck anywhere? And basically, I want to be ensured that after the facts, the verification is working okay. And let's see. This would be the last time I would be cross questioning it. So, this is the actual test, to be honest, like making sure the local setup works well with your code. And as you can see here, it's saying that it got these two outputs. So it says that the test was actually successful. Now I want to verify all of it myself, especially the post verification part, because after having seen the local setup giving me responses as successful and then later saying, okay, it made a mistake, just makes me lose trust on these models. So I will verify it manually. Now let's verify it manually. So I'll create this model that we have of lesser size. And now I'll run the main Python file. And if you see here, we get the message saying invalid model file detected, re-downloading. And it's downloading the post model again. And now it has downloaded and the app is working because I can see the good posture message appearing. So that basically means the fix that has been done is actually working. We have verified it manually as well. After having done this long testing, I feel I have few observations that I want to share. The first is the responses are pretty slow. So if you are somebody who is in a hurry or who wants to get tasks done quickly, then you may want to skip this setup. The second observation is since the model was not reliable, it was hard for me to trust it. So at the end, I have to manually verify if the changes were correct. So that again means when there is a task that is critical or let's say having high stake, I would usually prefer not using this local setup. And the third observation is if you actually want to use the setup, then you may have to cross question and then verify the things yourself to ensure that everything is working correctly. It's not like you can trust and blindly follow these models. So that's another takeaway that I have. And with this, we conclude this video. And Gemma 4 is not something that I would consider usable for my coding task. So I'll keep on doing these experiments, let's say with other local LLMs that are in the open source space or which are having open weights that I can run. The idea is to come up with a local setup that is actually useful. So in this video, the Gemma 4 model has failed the test, but stay tuned for more such videos and let me know which model should I try first. I'll see you in the next one. Bye-bye.